So I have to update today's code because when I try to run it, the code, somehow GitHub has the internet connection problem. I always run into something like SSL premature termination, the server side. For some reason, there's the GitHub has some connection problem. So I decide to manually download the data set and then add it into R. So hopefully that will solve the problem for today. I actually this happened very rare. GitHub used to be a very reliable. Oh, wait a minute. I just realized there's a hurricane coming. Maybe that explains it. Yeah, okay. Now I look through the window, I see the rain is coming. I realize maybe there's a reason for that. Yeah. So, okay. That explained. Okay. So, well, there's really not much change. The only change, well, the major, I would say the major change is really, I manually download the COVID-19 data set. Instead of reading from the website, now we read it locally. Apparently, because of the hurricane, there is some connection problem. Let me increase the screen a little bit. If I increase the screen, then you don't see very much. Okay. Probably even more. Okay, a little bit. Okay, it's good enough. Yeah. Okay, so this is so. Last time we go over chapter 2, we learned how to use the so-called wrangle the data frame, properly modified, and then we learned to do some single plot. There's one student actually tell us why there's some backtracking a negative number in the Hamilton County Health Department data. Apparently, there are some maintenance issue or oh, hold on, someone is coming. Okay. So I think one of the lessons I'm trying to emphasize is that we always want to verify the result. Given nowadays there's so much computer hacking, that's probably become more and more important. Because people don't have to steal things; they can just subtly change something, make you think you did it yourself. Right? Now that can make it even more. Basically, you don't even know something is wrong. You think it's correct, and you believe it. That's actually is even more dangerous than just direct, very malicious attack. Yeah. So, if you don't even know something is wrong, that's actually the worst scenario. So okay. So let me. So on the Socrates, I have a few questions just to make sure. Hold on. Let me. Now I have to increase the screen. I don't even see the whole thing anymore. Okay, so I'm going to go to the next question. Okay, this is just to make sure everybody is on the same page. Hopefully now everyone installed it. Okay, I'm going to move on to the next question. Okay, so if you are giving a data frame called TB, how do you find out what are in row 100, 105, and column 5 and 9 using R? I asked the same question last time, but this time I think again, see how many of you get it right. So. This is basically repetition. So it's like playing piano. How do you make it perfect? You just practice and practice. So. Hopefully, when you actually doing your job interview, you will get this question perfectly. So, yeah. Although this question maybe is too easy for job interview, but then it could be the entry level job interview, right? Okay. I see now. Yeah. I think I now see half of them are perfect answers. Yeah. Very good. Yeah, some of them are still using uh, the colon sign, but majority are now use concatenation to get it. Very good. So, all right. So basically, this is the perfect answer. Yeah. But so very good. It's obviously many of you returned know how to, I guess, paid attention last time. So I'll just move on. So if there are enough student answered, I guess. Yeah. Okay, I'm going to go to the next question. Okay, please describe what the function DIFF does in R. So this is the function we used it last time. Okay, 10, good enough. Calculate the difference between two elements. Calculate the difference between consecutive elements. No, that's not correct. It's consecutive rows, consecutive element. It's basically 1 and 2, 2 and 3, 3 and 4. Yeah. So difference in value, that's actually is ambiguous. I think the most correct answer is this: find the difference between consecutive elements. Although in a vector or list, what are those? So I guess that still can be included. Oh, here's one. But this function calculates the difference between all consecutive. This seems to be the most complete one. Yeah. So, very good. So someone seems to know how to write this succinctly in one sentence. Yeah. Okay, very good. All right. Next question. This is probably an easy one. What does dollar sign do in R? Okay, good. Specify just a row or column. No, that's incorrect. This is for column, not for row. Dollar sign is for column or a variable. A row is observation. So indicate element, that's also wrong, not an element. Yeah, so apparently, okay, maybe I should ask this question again next time. So this is already the second time asking this question. So, yeah, but it looks like many of you got it right. Column, 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 column. Okay, majority of me that did get it right. Yeah. Search for specific column. What does that mean? Specific. Oh, maybe someone want to say specific column. Okay, okay. It identify. No, that's incorrect. Get the name of this actually is a bit ambiguous. Get the name of a column. Not exactly. This is not trying to get the name of the column. Select variable. This is actually is yeah. That's actually is selecting variable. So up to assign variable. That's this is incorrect. It's not. This is not us. Well, it can be used to assign value to a variable. But, I guess this is not completely wrong. This can be used to do that, although that sign itself is yeah. This is I would probably just give partial credit for this. So retrieval. Okay, that's actually is correct. All value are specific variable. This is actually is correct. This is what it does. Although this can be more add more detail to make it more complete. Okay, good. For it looked like I would say 70% got it correct, so it's actually not that bad. Yeah, it's much improved from last time. Okay, so this is a question, a bit challenging question from last time. So, given the Johns Hopkins COVID data set, how do we find out how many counties in Tennessee? This is the question I went over time last time because I think I made at least typo twice. I tried to figure out where the correct them. And this is not a closed book. You can actually look at your notes from last time. I'm trying to answer it. By the way, none of my questions are closed book anyway. So, yeah. Okay, well, someone answered it very fast. I'm going to wait, let a few more students have the opportunity to put the answer there. Then I will look at your email. Okay, 5 good enough. Let's see. How the well, someone actually want to use regular expression. The data. Okay, what is that? Okay. This is actually won't give you the number. If it good, hold on. Let me think about it. Select. Oh yeah, actually that will give you how many counties because each row is unique. Yeah, actually that is correct. Yeah, this one is correct because each row is unique. So this should give you the Tennessee admin tool, I guess. Yeah. Oh, okay, very good. Someone really look at the notes. Yeah, so very good. Yeah. Oh, okay, that's for today. Okay, very good. So let's start today's. Now that many of you have a good grasp about chapter 2, let's move on to chapter 3. I remember for chapter 2, some of you already say we did the simple plot. That's not a very useful for comparison. Someone want to say do a overlay plot. Very good. So now we trying to do an overlay plot. So the goal today, we need to merge two data sets. So what we are going to do, we're going to get a Google mobility data, and then want to merge the Google mobility with the Johns Hopkins COVID-19 data. And then we overlay the Google mobility with COVID-19 cases. So this is the what we are to. So we also want to know what can we do to stack the data frame. This is actually stack the data frame is it literally is stacking the data frame because in R, data frame are organized by column. If two separate data frame, they come in exactly the same format, means each column are exactly the same thing. We can just stack them. This is literally metaphorical speaking, is or figuratively speaking, is just stacking two data frame. Yeah. So okay. So this is the part we have to download the Google data separately. So once you download the new zip file from Canvas, so if you download that zip file, it should already have the Google mobility data there. So, and then we should be able to run it. So you should be able to run the code. So, and this is, let me go go back to chapter 3 today. Chapter 3, okay. It's too small. Okay, so we are going to analyze Google mobility. So Google mobility is Google mobility. Google Community Mobility Report is basically trying to use anonymized cell phone movement signal to compare how people travel with so-called baseline, basically in normal times before the pandemic, right? So well, maybe I should let you read the Google Mobility Report itself. So what is the community mobile? It actually does has a very is that PDF? No, it's not PDF. Learn about the data. Oh yeah, this good overview. Yeah, so it basically had a baseline. Apparently, baseline is the median value from the 5-week period, January 3rd to February 16th. Oh, that actually is a bit troublesome. That means the United States COVID already started. I guess it assumed people didn't really react at that time. That's an interesting choice, by the way. Oh, I see. Before that, Google didn't do anything, so they do not have the data. So after the COVID, they realized they need to do something. Then they start to collect this anonymized data. Okay, that seems to make sense. So even though ideally they should use data from 2019, but they don't have that data. So that seems to explain it. Okay. Okay, so that's good enough. So yeah, so
yeah, but the data shows
once we start to analyze, and you will see how this can be used to so-called to estimate social distancing practicing, because one of the best way, well, I wouldn't say one of the best way, one of the effective way, based on the mathematical model to stop the spread of disease is so-called social distancing. Although there are other ways, that is assume there are no other preventive method like vaccine or masking or the social distancing is one way. So okay, so we have the data. Now we read. Now apparently Google separate the mobility data by year. So once you download the data, you extract it, and then you will see a lot. In fact, that have many countries, but I only left 2 United States. And apparently Google also separated the data into 2020 and 2021. So now we have 2 files. But the good thing is that 2 files have exactly the same format. So if we open that using Excel, sorry, on Mac is actually open up using numbers. Yeah, sorry. On Mac, my default is numbers. It's the Mac version of. Maybe I really shouldn't open it. It seems to really take a while. I'm going to close it. Sorry. Okay, it's actually 82 megabyte CSV file. That the 2021 62.6 megabyte CSV file. Let's just look at it in the R. It will be faster than using an Excel spreadsheet. So, okay, so we are going to read basically 2 files. The 2020 file, I call it TB, GM Google Mobility US 2020. So we read that actually I already run the code. So if I just show you that, it would be more easy. So there, we read that the CS3 that 2020. Wow, you look at this, 812,065 rows, 15 columns. So there, right there, you will see Google Mobility and Johns Hopkins data, they use completely different format. So, and then if you look at this is the last few lines of Google Mobility 2020 results, then we see, well, country, United States, Wyoming, subregion. So there you see in the Johns Hopkins data, each county is a single row, but in the Google Mobility data, no, each county clearly is redundant. And so the Google Mobility decided to order the column by time series. Johns Hopkins COVID-19 data decide to order by rows. Those are the time series. It's really hard to say who has a better choice here. Although I think Google makes more sense. But that's it. You can see if you order using the way Google does, your file size will be much bigger because there's so much redundant information there. That said, SQL, if you use database, you'll realize this is an ideal way for computer to read it. So I think Google designed its mobility report with the computational analysis in mind, because this is so easy to read into R and do data analysis. So we Google Mobility uses this format. So okay, so and then we read it again from the 2021 Google Mobility data. You will see they have exactly the same format. 15 columns, country, region, subregion 1, 2, metro, and then some other like residential, workplace, transit, park, grocery, retail. Those are all percentage change from baseline, so plus minus. Right? Baseline will be a change is 0% change. The same thing here. So workplace, residential, change from baseline. Now baseline basically is the first 2 weeks of 2020. So okay, so and Google Mobility also use different format of the location. The state is still called Tennessee, but the county now is called Hamilton County. In the Johns Hopkins data, that one doesn't have the word county in the county name. For some reason, in the Google Mobility, decide to put a county in that county name. So, and there's no reason to say which one is better. It's just because this is generated by 2 different companies, and you have to use different. They generate using different standards. So this is one of the reasons we have to. When we have to do data analysis, very often we have to do so-called heterogeneous data set, and we need to learn how to merge and harmonize. So-called harmonize actually also means other things. You need to convert a different convention, different meaning. But for the time being, we just merge it. Harmonization have some special meaning in biomedical data. That's because you have different insurance, different hospital, different physicians, right? Different medical code, different billing code. This actually in biomedical data analysis, harmonization is a big deal. Yeah. So okay, and for us, we just basically merge them in a way. Yeah. So, and using the Google data is even easier. We just stack them. That's all we can do. And they are already for the Google Mobility 2020 and 2021. We don't even have to do something special to merge them. We just stack them. This is so-called a stackable data frame. So, okay. So, let me see. Okay. So we're going to pick Hamilton County, Tennessee. This is also because our COVID-19 data set is also from Hamilton County, Tennessee. So if we pick a different mobility, merge with Tennessee, I mean, what are we going to do? It really doesn't mean anything, right? So we picked Hamilton County, Tennessee mobility data. Sorry, I just realized I have a title right there, so I'm going to ignore that. So, okay, so we're going to pick the Hamilton County, Tennessee mobility, and then merge the COVID-19 case data, also for Hamilton County, Tennessee. Oh, here, sorry, I skipped the stacking. This is basically what the stacking do. It's a very simple command, one R command, R bind, and then we just put the two data frames together. So this is so easy when everything is stackable. So, yeah, so we just literally add these two, concatenate them together, concatenate two data frames. 2020, 2021, two data frame. We add them together by row bind, R bind. So if you do a R bind, and you will see a help information there. Combine R object by row dot by column. C means combined by column. R means combined by rows. In this case, we are combining two data frames by rows. Let's add them together, I bind. And this one should have some example information. You can study them to see how exactly the R bind and row bind are two very common practice we handle. So if you want to actually really experiment this, you can actually, let's see, I'm going to say X equal C, A, B, C, D. I'm going to say Y equal 1, 2, 4. Okay, if I see row bind X and Y, this is what it is. It's basically treating X and Y as a row, stacking them. If I say column bind X and Y, it's basically each one is by a column. So this, but now that we have two data frames, that means we are going to stack them like this. And the previous one, everything will be stacking together by row. So, yeah.
How about if the dimension is different?
So in a way, exploration is just using a few simple example. Exploration is often the best way to know how the function works. So, okay, let's come back to this. So there, that's a one-line code to combine the two Google mobility data. If you want to do that using Excel, it will be a bit cumbersome, right? So by using R, you have two separate files, merge them. There, for a stackable data frame, that's just one command it does. Okay, So now the merged data is called TB Google Mobility US. And then I'm going to pick subregion one. Subregion one is what? A state. Why do they use subregion one? I guess Google Mobility trying to do this for the entire world. And the US, you have state, but in many other countries, they don't. The US is very unique in that sense. It's called United States, but every other country, they are a state by itself. The United States is considered a separate state or separate country, United. So, yeah, I guess literally that's what it means, United States, right? So Tennessee is a state, but in many other countries, a state is just a country by itself. So that I guess they use subregion one, subregion two is also metro area. Well, yeah. So anyhow, so that's basically Google decided. So at least in this case, subregion one is the Tennessee state. We pick that Tennessee state. Subregion two, we pick Hamilton County. So, and then we will have the I call TBGMI county, basically Hamilton County, Tennessee. So there. Currently, that's what we have. That. There's something in between. That actually is the date. And apparently, Google Mobility is not updating every day. Today is what? 30, and the Google Mobility is only what? August 25th. Can you double check that on your own code? What do you find? So
I just ran out my code and I got the 25th.
Yeah. On your own funnel, can you put the output when you run our code, what is the most recent date in the Google Mobility data you find? Okay, very good. Majority of them, all the students who put in is August 25th. 2021, August 25th. Okay, very good. That means we are all on the same page. So very good. So it's actually, okay, that's good enough. So, oops, wait. Okay. So then that means if we merge Google Mobility with the COVID data, the COVID data actually goes all the way to yesterday. This is our COVID data, daily cases from COVID data, Hamilton County. And it actually goes to August 29, yesterday. So if we merge the Google Mobility and the COVID data, that means we will not get a perfect match. We have to either lose some or figure out a way to fill in some. Basically, it's not going to be a perfect match. So this is often a decision in practice people have to make. You have a heterogeneous data set. If you merge the two, very often you will not have a perfect match. So then you end up with a decision, how are you going to treat those unmatched data? In my case, I basically pick all the dates. I merge them by the dates, which means the dates who are missing from the Google Mobility will be removed. So in my case, I merge the COVID data with the mobility data. How do I merge? I merge by the date. all y equal 2 means I'm going to keep everything in a Google mobility data frame. All dot y equal 2 means I'm going to keep everything in a y. What is y? Y is our TBGM my county, which is a Google mobility data frame. So merge is the R function you really want to understand how it does. So they actually, if you look at the help information, for some of you still remember discrete math, hopefully. You will know when you merge two different sets, you have the in join, outer join, left join, right join. There's various kind of ways you can join the data frame. By X, by Y, all. I don't remember all this, and in fact, I wouldn't trust my memory how this does. I always double check all this to make sure I know what I'm doing, and then I run a code. This is again the parameter. When you apply it, you need to know what you are doing. So oops. Okay. So okay, now my question, after we merge, can you find out what's the most recent date in this TB COVID my county table? So I'm going to open my Socratic. I think I didn't have a question here. So I'm going to type my question there. So the question is, after merging mobility and survey data for Hamilton, Tennessee, what is the most recent date in the merge data frame? Okay, that's the question. So, oh, this is not multiple choice. So I need to put okay, this is the short answer question. So so the question is, so after we merge the Google mobility and COVID-19 data set for Hamilton County, Tennessee, what is the most recent date in the merged data frame? Very good, yeah. That should give you a, no, it shouldn't be August 29, no, hold on. Let me double check. I need to decrease.
You just passed it at line 260.
Really hard to see the
I think a few of us were looking at a step before the merge at tail TB daily my county where it shows 29th having 0 daily cases.
Okay, so now I merge the two data sets. Another recent date is is that correct? Okay, I got August 25th. Okay, I'm not sure those who got August 27 or 29, then you have some issues there. I got August 25th, so. If you are not sure, you can also check the actual data frame here. So it should be on the top right panel. So let's see. TBGM, I show it. There. Oh, I see. If we do this, if you want to look at the last one, you have to scroll all the way down. Yeah, also, yeah, here is also August 25th. So. Oh, we got a 0 again? Because, wait, is that the month? 25th, what is that the, what is 25th, by the way? Oh, it's a Wednesday. Okay, wow, maybe it is a good news. It is 0. Okay. Okay, interesting. Okay, so in this case, I guess it is a true 0. That doesn't seem to make sense, does it? I mean, you have several hundred, then becomes 0. That seems to be a little, seem to be too perfect. So right, that seems to be a little less convincing. Yeah. So anyhow, but somehow Wednesday we have a 0 case. So, but there's not much I can do. Oh, someone is a chat window. Hold on. Oh, I see. Someone actually is analyzing Montgomery. You need to change it back to Hamilton County, Tennessee. So. Okay, so there. Hopefully, for those who are still having trouble, you need to go. There must be some typo someplace. Yeah. So. I shouldn't say there must be. There's probably because I'm not working on your computer. So yeah, I would say there's probably a typo somewhere. So yeah. Okay, so now we have to do overlay. Now, before we do overlay, we actually need to so-called normalize the data. This is because if you look at the Google mobility data, the case data will be several hundred, and then you look at the Google mobility data is often a few digits, and it can be also negative and sometimes a positive. So if you without doing any normalization, you plot them together, it'll be really hard to see. Actually, let's just put that exercise later on. But for now, let's just do the scale. But we're going to come back doing do a non-normalized overlay. Let me write it that overlay. Yeah, maybe at the bottom say overlay is not normal. Okay, but for now, let's do a scale. We have to normalize them. That means putting all the data in the same range. It's actually, if you recall from statistics, this is basically the z-score calculation. This is basically the z-score calculation. So apparently, well, if we want to normalize it, we can only normalize numbers. So I pick out the numbers. I call it the TB COVID number 2. I think that's, I thought I wrote this code. Oh yeah, it's already here. Yeah, but because the name is, yeah. So hold on. Is it normalized? It doesn't look like normalized. Oh no, that's not. I just picked the number. The normalized called scaled. Scaled, not scared. Scaled. Sorry. Apology for my pronunciation. Scaled. So okay, this is a normalized. So that's just the number. Apparently the first case in Tennessee is March 13th. I think that's a church, a pastor or something. Yeah. So, but by then you see there's not much change. People are still going shopping, but after that, you see people are not going to shopping anymore. That the retail recreation changed from the baseline. It decreased almost 50%. You see when the case increasing, it start to decrease. So people are not going to shopping anymore. People are still doing grocery because you have to buy something, I guess. So even though it goes down, but the people still have to do grocery shopping. Parks and recreation goes down. Bus station, there's not many people doing bus, or very few people going to work. But most people stay at home. That seems to make sense, right? You have to stay someplace, right? If you don't go to work, don't go to park, don't go shopping, where do people stay? So, yeah. Okay, that seems to make sense. Right. And then if we look at the scaled, now everything become a z-score. So that's it's all z-score compared to that column, by the way. So in fact, we can actually look at the what is that column? Scale, yeah, scale. Scale is a generic function centered or scale the column of numerical, right? Center the column or a matrix. So scale center is true. Scale equals true. That's basically it. So center everything around the center. My interpretation, that's the median. Yeah, you can see it's basically the standard deviation formula. Yeah, basically there, dividing the center of the column by their standard deviation. Right? So it's basically a z-score. This is basically a z-score calculation. Right? And if we go back to my HTML output, right? So we merge that. Right, normalize. Scale. Now everything becomes this form. So, and then overlay them. Oh, in this case, I added the dates back because after, when we do a normalization, everything is still treated a numerical metric. Then we add the dates back. The dates actually we keep the dates as a row name, so that's like easy for us to track it. It's almost like an extra precaution. So we have the row name always labeled there, and then convert back into dates. So we won't mismatch it. So it's just my own habit to double check it, you know. So, okay. So now we can now overlay the scaled values. Now, currently, if we want to do overlay using ggplot, we have to put all the value in the same column. And then we have to put a matching another column to label which of the value come from which category. Personally, I think this means the ggplot is still not developed very well. But that's the current method we have to do. So in this case, we are going to overlay what? Daily cases, residential percentage change from baseline, and workplace change from baseline. We are going to overlay these three values. What we have to do is we have to melt them. That's the table. That's the column we're going to melt. And then we put this at the value. And the name will be something called variable. That's actually seems to be a little really strange to read it. So if you look at the df melt, maybe you will understand this much better. D should be at top. Okay, there. There. So hold down that. Yes. No. Oh yeah, here df melt is right here. So the values, those that must be case number. So daily case initially is not available. So the variable, but what those variable means, that's not available is what? Daily case. The date is what? February 18. And then we see February 27, daily cases is now -7 something. And those are all daily cases, all the daily cases. When you go all the way down, it should become changed to something else. Remember, wow, this is really I should change it to a smaller table so I don't have to scroll all the way up and down. Okay, now it's changed. So now it changed to residential minus something date. So what this means, we have to plot everything in that value column, but when we color them, we color it by the so-called variable. And the variable basically are those overlay data we have to do. And the dates are there because we have to overlay, do a time series plot. We're going to plot a value versus a date, and we color them by the variable. So if we go back to there. So I'm going to plot this melted table we are going to do the horizontal will be the date. The vertical are the values. And we're going to color them by the variable. And then add the smooth line. And then I'm also going to put a county name and state name and just make it clear. This is basically how it looks like. So we have the daily cases, orange, residential change from baseline, and the green. And the blue is workplace change from baseline. So that's the Hamilton County, Tennessee from that February 2020 to August 2021. So it look that must be the Chattanooga shutdown, and so nobody goes to work, and then everything open up again. So you see people all stay at home at that time, and then when people go to work, or then during the holiday break or the winter break, people stop working again, stay at home. Right. So now it is in July, I guess in the summertime, people also go to work less. I guess in the summertime, people go outside. Okay, but then residential goes down. I'm not sure what that means. Residential goes down in. Oh, that's because the workplace goes up. Residential goes down in. That's probably April and May. But now both residential and workplace are going up. Basically, people are we behave more and more like a normal now. And the daily cases seem to be it's right here now as of now. So last year July, this actually still goes down. It's peaked. There's a summer peak. Then it goes down. But this year, apparently, there's a summer peak. It goes up all the way to August. So there's no going down this in 2020. So last year, when it goes up in July, it actually then goes down. But this year, it's just all the way up. So that's basically Tennessee with Google Mobility. So okay, now for the exercise. Hold on, where is my code? Wait, did I close my code? Where's my code? Oh, here, okay, it's back. Because I have too many windows open, I need to close some. It's actually, I have so many windows, it's actually minimized to the left. So, by the way, that actually reminded me that one time the student had a trouble say, I just couldn't see my plot, couldn't see my help menu. It turned out that student scrolled this bar all the way to the very right. And so those two windows just minimized all the way to the right. And it took me and that student a long time to realize that problem. Yeah. Yeah. Okay. That's just one very funny thing happened. That probably is I would think our studio should disable it. Otherwise, it's really confusing. Yeah. So, okay. I know. So just be mindful when it happened to you. Yeah. Okay. So the question. Hold on. I think the question is, do an overlay without a normalization, see how it looks like. So I'm going to, this is 7 o'clock. We have about 15 minutes left. So let's work on it for 7 or 8 minutes and then can someone share their screen, see how it looks like? So I'm going to stop sharing so everybody can work on it. I'm also going to work on it. And then maybe up to, with 5 minutes left, let's come back and see how it works. So.
I have a quick question. If what does the value.names and the variable.name actually do on the DF melt?
Yeah, anybody else getting an error with DF melt?
So what were we supposed to do?
I don't think he can hear us actually. I think he has this
Yeah.
muted.
Yeah, but what are we supposed to do? I forgot.
Oh, you're supposed to plot it without normalization.
Mic check, professor.
Mhm.
I think you have, I think the students probably might be muted. It might all be, I don't know, maybe your sound is on, but I think the probably.
Oh yeah, you can turn, you can unmute yourself if you want to talk. Sorry. You can unmute yourself.
Can you hear me?
Right now, they're talking, but I'm reason you can't hear them.
Oh, sorry. I minimized my speaker. Sorry. Yes. Question.
Yeah, I have one question.
Okay. Yes.
What does the let me see, the value.names equals values and the variable.name equal
Can you share
variable?
your screen? Can you share your screen?
So
Mhm.
the part right here,
Okay.
I'm not sure what that actually does, and I've removed it and everything still works, and I can't find where.
I think by default that's what it is. So if you remove it, it's okay.
Okay,
We are just using the default name anyway. So
gotcha. Okay, cool. Thank you.
So if you remove that one, it's okay, unless you want to rename it. Yeah.
Okay.
Basically, what? Let me ask a question. Someone actually did show a screen. Okay, let me see. Someone put in the chat window. Oh, excellent, very good. Let me see. Let me share my screen. So, can people see what the file in there? How do I pronounce your name? Monreal? Can you pronounce your own name?
Monira?
Monira Rahmati?
Yes, Rahmati.
Rahmati. Okay, thank you. Oh, excellent. The people see that? Yeah, very good. So that's yeah. I think that's almost let me show this two figure. That's almost exactly what I got too. Yeah. Very good. So yeah, so Monir, can you share your screen to explain to the class how you did this?
Sure.
Yeah.
Can you see my screen?
Yes, I see it. Yeah, very good. Yeah. Can you show the code and explain to the class how yeah.
All right, this is the code. Actually, I just removed the variable which was scaled to the original ones, and I got this plot. So here at this point, we had something scaled. I removed that one, and I think we had it somewhere else, which was.
Oh, I see. Okay, yeah.
I just.
Yeah. Okay, so you're basically using the old before scaling. You just plotted that data. Yeah.
Yes.
Okay, good. It worked. Yeah. So Yeah, very good. That's a very simple solution. Actually, it's much more simple than mine. I actually regenerate a table, then do it. So very good. So that's actually, I didn't realize we already have that in one place. So yeah. Very nice. Anyone had questions to ask Monir? Let me see. Let me see whether if there are other things I need to go through. Yeah, I think that's it. Yeah. So, and so let's summarize. Okay, Monira, can you stop sharing?
Sure.
Okay, thank you. So let's conclude today's so we go through chapter 3, and today we basically try learn or exercise merge two data set, Google 2020 and Google 2021. We also merge the Google mobility with the COVID-19. So that's what the merge and harmonized heterogeneous data set is. We also learn to stack two data frames when they are compatible, like Google 2020 and 2021 mobility data. We also learn how to do overlay using ggplot. Let's say that there are different ways to do overlay using a basic R. That's actually much easier. The overlay in ggplot, it looks more prettier than the base plot, but the syntax seems to be a bit non-intuitive at the moment. Yeah. My guess is someone need to simplify the syntax in future versions. Otherwise, this is just a very seem to be a little non-intuitive. There's an extra layer there to do the overlay plot. Yeah. So, okay. Any other questions? And for those who still need to sign in, I can go all the way back. So. Yeah, you can. For those who haven't signed in, you can still sign in. Actually, probably I think everyone already signed in. Those who hasn't signed in probably already dropped off the Zoom anyway. So, okay. If not, I'll see you Wednesday then. Yeah. So Wednesday, we are going to do the chapter 4, which is do a more analysis of the weather data. And if you recall, at one point we say summer will come, COVID will just disappear. It didn't, but we can't overlay with that. Yeah. Okay, see you next time. Bye.
Why should we scale the data?
Sorry, what?
Why should we scale the data?
Why? Well, if you don't scale the data, how does it look like, right? So you can compare the scaled without scaled and see how it looks like. So yeah. So basically, you compare the scaled overplot versus non-scaled, you will see the difference.
They both look cute.
Sorry, what?
They both looked good. Okay, I see.
Not really. I mean, it depends on. You should look at whether they are informative or not. So.
Okay.
Yeah.
Thank you.
Basically the non-scaled data, all the small change will be over dominant by the large numbers. So
So we scale for accuracy?
It's not for accuracy. So non-scaled is actually more accurate, but the human eyes cannot tell the small difference.
So we scale for visualization.
Right. Yeah. So,
Thank you.
okay, bye.
Bye.